Alright, so today is really going to be kind of a short day for our lesson. And so we're going to be working on the segment addition postulate. And we're going to have a kind of a nice little saying that kind of goes with it. It'll be the motto for this lesson. Actually, it's one of those big ideas for this whole course. So it's a really simple thing to remember. So go ahead and get you guys started here looking at our objectives for today. Very straightforward, very simple. And that is use the second addition postulate to solve problems. Okay, very simple objective. Let's go ahead and take a look here at the concept behind this. And like I said, it's a very straightforward concept. What do you guys see there on the screen? I have ACB. Tell me something you guys notice about ACB. A couple of things. Alright, segment. Which segment? AB is one of the segments. Okay, what else do you guys see? Yeah. Okay, the segment BA and AB, good. Are there any other segments up there? AC. AC is a different segment, and so is CD. Very good. What's special about the placement of C? It's definitely not the midpoint. It could be, though, right? Yeah, I think we can clearly say by this diagram it's not the midpoint. But more importantly, it is between A and B. And that's really important, that C is between A and B. So what could you guys tell me? If I took AC, there we go. If I grabbed AC and brought it down, and then I grabbed BC and brought that down, together, what would I get?
AB.
I get the whole segment AB. This is not a challenging concept. It's really that simple. All the segment addition postulate states is that the sum of the parts equals the whole. That's the big idea. That's what you need to write down. The sum of the parts equals the whole. It's a very, very simple concept. But when we talk about geometry, we have a lot of theorems. We have lemmas, which that's more for advanced mathematical topics. And then we have these things called postulates and axioms. All a postulate is something that we just take to be a given understanding. So it's something that we already take to be true. What do we have to prove that it's true? We take that as a given. And it's kind of like definition of those points. We don't really define what a point is. We just kind of treat it as an axiom. In true geometry, in mathematical geometry, we have 5 axioms and 5 ground understandings. Okay, I think the ground rules, right? So you guys have the ground rules in your other classes on the first day of school. It's similar to that. And I'm not going to go into those in a lot of detail for this class. But just understand there are 5 ground rules of geometry, and we'll discuss those as they be. So that's kind of what a postulate is. It's just really it's a ground rule. So the segment addition postulate, again, sum of the parts equals the whole. If I take AC, all right, let's go ahead and write that down. That's kind of an important way to do that. We take AC, add it to CB, we get AB. And then this guy right here, the whole thing, collectively, is what I like to call the geometric equation. Before you guys start any problems, the first thing you need to write down is the geometric equation. What 2 parts are you adding to get the whole? Then from there, we can start bringing in the algebra. But it's really important that you start at the geometric Because that gives us now a framework to work around and to start putting the correct values where they go. So that's kind of an important part right there. So again, sum of the parts equals the whole. That's it. That's the whole concept. And then it gets really easy. So what I want to do right now is I'm going to have you guys help me out here. I want you to give me a geometric equation that I can use to find these lengths. So let's say I'm solving for QS. What geometric equation would you write to find the value of QS? QR plus RS equals QS. Very good. What about number 2, QT? And a lot of times we like to keep them just as 2 pieces. So we could say, well, we could do QS plus ST is QT, or you could also say that QR plus RT. All right, what about PR? Brian, what do you think about for PR?
Probably PR and IT.
Okay, we're just doing the segment from P.
PQ and QR.
PQ added to QR is made PR. All right, and Jake, what about number 4 for PS?
PQ plus QR plus RS.
Again, we can look at this in a lot of different ways. The QR plus RS could also just simply be QS. So there's a lot of different ways we can look at these. That's kind of like one of those nomenclature and conventions that we do for geometry. And we never use 3 letters to represent a segment. We simply represent it by its 2 endpoints. Okay, we think about angles. When we do angles, we use the 3 letters. But for segments, we only use the 2 endpoints.